So combined gas law is going to be PV over NT equals PV over NT. So now let's see what information we have. All right, so it says the volume of a gas is 38.2 milliliters at 26 degrees Celsius and 0.953 ATM. So before I even keep reading, I'm just going to go ahead and let's start writing this stuff out. So it says volume is, right, so I can say volume 1 is going to be that 38.2 milliliters. What is that in liters? Move that decimal 3 times to the left. Good. Okay, so we have our liters. Next thing said 26 degrees Celsius. What is that? What is it? Oh, yeah, what did you do? You added 273 to it. What did you get? 99? Okay. All right, but what variable is that? That's what I was trying to ask. Temperature, yeah. So this is T1. Okay. All right. And then 0.953 atmospheres. What variable is that? Yep. Pressure. So the reason I'm asking that is because sometimes we give you a problem like that, right? Where we're not saying the volume is, the pressure is. We're just giving you the numbers with their units, and we expect you to look at those units and know what they're representing, right? So pressure, atmospheres, okay. 0.953 ATM. So if you notice, there was no mention of a mole, all right? So we're probably going to get rid of that, and that's just because usually we don't mess with the sample size, okay? All right, so then the second half of these givens, it says, what will the volume be? So V2 is going to be who we are looking for at 17 degrees Celsius. So that one's temperature 2. So that one's going to change to, what was it? 290, yeah. Okay, 290. And then pressure 2 is listed as 0.8986. All right, so real quick, what's happening to temperature? Temperature is going down. What's happening to pressure? What? It's going up, right? So temperature is going down, pressure is going up. So what's volume going to do? So looking at how this thing is listed out, we know that pressure and volume have an opposite relationship, right? Inverse relationship. And we know that volume and temperature have a direct relationship. So basing it just on temperature, what should volume do? It should go down, right? Direct relationship, down. According to pressure, pressure goes up, what should volume go? Down, opposite, right? So ultimately, we are predicting volume should be dropping, right? Okay, so when we go to plug all this in, this is the fun part. It looks worse than it is, I promise. So 0.0382 all divided by temperature 1, so 299. And I'm going to set that all equal to pressure 2, which is 0.986 times volume divided by temperature of 290. Now, it looks very scary for some of us, okay? It's not. I would just keep doing what we've been doing, the diagonal multiply, okay? So multiply the 3 numbers going diagonal from each other, and then you're going to divide 299, divide 0.986, push equals. So you're literally doing the same exact thing. You can just push divide as many times as you need to, okay? You can always rely on that. So again, first step is those three are getting multiplied together. Get that answer on your calculator and then divide 299, divide 0.986. I would make sure that you can get to this answer, because the only way that you'll know whether you're having issues or not is by trying it. You want to be getting to 0.0358 liters, or 35.8 milliliters. So see if you can get to those two answers, or that answer. So you can start looking at the other side. That's when we look at it. You didn't divide by 0.9, I'm sorry, by 986, so you added extra zeros there. So if you would have, here, let me just, so that was your first thing, right? And then you went to that was your second thing. And then you would have gone divided by, now put 0.986. Now you got it. Okay, all right, yes. All right, so check your neighbor, make sure they're good.